I'll send you an invite to our website. Carry on. You're very welcome to start writing the blogs. Licenses. Anybody who wants a license for Sea Lion, what you need to do, you need to send me an email. I'll quickly write the email address if I find the marker. So it's tom@pcservicegroup.co.uk. In a subject, put Sea Lion license. Inside the body of the email, put your name, your surname, and email address. So I can just copy and paste. And I will email you a license back. Now, I've just run out from the licenses, the batch I had, and I'm hoping to receive another batch very shortly from JetBrains, but I don't know exactly when they're going to do that. So bear with me before they will email me. As soon as they email me, I will give you licenses. And lastly, if you have any other ideas, about how we can expand and make this project successful, join us. You know, come to meet us. We have weekly lunches. It's always end of the week, so it's either Thursday or Friday. We meet up, well, somewhere around Moorgate. Usually we meet up in Eat, but recently we've been disappointed with their food menu, so we might change to something else. But you're very welcome. Let me know beforehand. I'll send you an invite, and then we can chat. So everybody's invited. Obviously, not everybody at the same time, because that could be a disaster for the place. We'll just overcome. And pretty much that's all from me. So I'll be passing you to Oliver as soon as he's back. Yes. Yes. So I won't be reading like bit inside the email. I just copy paste.
All done?
Yep, all done. You can
Right, hello everyone. After some technical difficulties, we're now running. Although I'm slightly out of breath, so give me a minute. Oh no, don't do this to me now. Come back. You've got to be joking. Okay.
Yay!
Woo. Lovely. So I see some familiar faces. Who wants to skip straight to pointers? Or who feels they'd like to cover references again? Hands up for cover references again. Hands up for the other one, just to see if anyone... Okay, cool. Right. Well, the usual first thing is feedback, please. Well, I think Tom's done it to death already. Would you love to hear from you? Feedback's always great, even if it's just putting up your hand and telling me where to go. Again, we are, of course, using the textbook. And hopefully this does what I want. It does. Right. Pointers. No pointers. I'm kind of stealing from him if you were here last week now. So, after you get them, this should be it. So, obviously a pointer is a value representing the memory address of another thing. So, that if you imagine that as something that's sort of represented by the architecture itself, so on a 64-bit CPU, as we say, I bought a Justin, close the door. You get a 64-bit CPU. then this pointer, oh wow, this is getting better and better. Hello?
Sorry about that.
4 guests. Okay, that's fine, you can sign them in. Cheers, bye. Alright, we've got 4 more people joining us. Wonderful. So in terms of your CPU architecture, this memory address is literally the size of what your CPU's architecture is. Obviously they're referred to as raw pointers these days. That's a relatively modern thing, of course, since C++ 11. Well, strictly speaking, probably since 03, because we had what was auto pointer, which was considered a smart pointer at the time, but it's in fact proven to be terrible. Never use it. If you use the latest C++, you can't use it because they got rid of it. We use them much less frequently in C++, which is a very good thing. You should generally prefer references. People do use pointers as a sort of either reseatable object or alternatively as an optional object, because of course you can have a pointer that points to something, so then something you can use, or it can be a pointer that points to null, and you know that if it points to null, there's nothing, you can't use it. So if you wish for something to be optional, you could use a pointer. I would argue don't. You can use std optional, but that's something for later when we get into templating and that kind of stuff. And as I just said, use references when you can, and a pointer when you really have to. And I believe we should be getting into what that really means very shortly. So, you can obtain the memory address of... Oh, we've got a lot of people coming. I'll just let these guys get settled. Okay. So we can obtain the memory address of a variable by writing an ampersand, the and sign, in front of the variable's name. For example, easy, right? So everyone understands that, or shall I explain it? Explain it? Yeah. Okay. So I don't have a laser pointer, do I? No. So obviously we have our lovely int I, 0. It's fairly simple, of course. This operator here, when it's applied on the left-hand side of a variable, or in technical terms in C++, we would call this an L value. It's an L value because it's a name that exists on the left-hand side of this statement. But on this variable, it says, give me the address of this thing. So the compiler is going to deduce auto to actually be int star. So this is a nice keyword that was introduced in C++ 11. That will actually have the compiler to figure out what it is for you from the right hand side. Effectively, yes. It gets a little bit more complicated because L values can be turned into X values via std move, and you can have a reference to an R value, but then that thing that is considered a reference to an R value type is an L value itself. But don't worry about that for now. That's way in the future. So, yeah, the variable ADDR has the type of pointer to int, which the compiler is just figuring out for you. You could just type int star instead of auto if you wished. You put an asterisk after the type name. I'm blaming Tristan for these slides, by the way. I would have just written that, but I know. Okay, he has. Never mind. Ignore me. So I don't have an advanced view, so I can't really tell what's coming. That's the old way of writing it. This is still perfectly fine. This is kind of just being a bit, what's the word? Smart ass, perhaps. Okay. So, also unlike references, a pointer is a value type. So perhaps a way of explaining this that's relatable is that you have, of course, your actual sort of type that you just get, like an int, a double, or maybe you declare your own struct or your own class, right? When you do that, as in many other languages, such as, say, Java, the class or struct is a type, right, in its own right. That is now a type, just like int is a type. An int is not a double, it's not a float, it's an int. Okay, there are ways to do conversions, but it's a type. And this applies to your own struct. So that is the type system in a nutshell. Now, when you have any type, whether it's the built-in one, whether it's ones from the standard library like std vector, right, or just your own that we'll call t. what you get on top of that, without you doing anything special, is you can then have a reference to your t, right? You can declare t and whatever equals some existing t. And that is not the same type as just t, because just t is the value type. So t and is actually a type in its own right, which is the reference type. And similarly, t star, the pointer to t, is also a type in its own right. So it's like, imagine you have your base type, and then these are sort of language built-in extensions to the type, and they are their own type. So a pointer to t is not the same as a pointer to int, obviously, but t star is not the same as just t. Is that a reasonably decent explanation for everyone? Yeah? Ish? Okay. We'll keep going. So since it's also a value type, you can actually copy the pointer, literally the pointer itself. So there's a very nasty thing that bad old code used to do, which was people would make assumptions about the size of the pointer and assume that it will always be that way. So imagine you wrote like a driver for the Windows kernel, for example, or Linux or whatever. Then, years ago, we all just had 32-bit CPUs, right? So they would just take what was a legitimate pointer value, a pointer to something, and they would just cast it to a 32-bit integer. Well, yeah, that will work fine on a 32-bit machine, but then we all got 64-bit machines. And now that code's broken because now the pointers are all 64-bit. So in terms of writing code, when you're dealing with pointer types, always keep them as pointers. Don't make assumptions about them and try and hack around the language, because it will inevitably bite you when someone from the business comes along and says, we'd like this to run on this other machine, actually. No, it's the amount of memory the pointer consumes is equal to your CPU architecture. So on a 64-bit architecture, every pointer is 64 bits. If you compile it as a 32-bit program, obviously 64-bit Intel and AMD can run 32-bit stuff still. So then it would obviously just be 32 bits. Linux actually extends that. You can actually have 64-bit code using 32-bit pointers. But that's a feature that Linux has. They are also variables, right? So, well, okay, I'm not sure I like this the wording of this one, but you can take the address of a pointer as well. So then you have a pointer to a pointer, and you just go a pointer to a pointer to a pointer to a pointer. You can keep on going up. Did he say this? No, he didn't. So the caveat to taking a pointer to a pointer is that you can't just do and. So you couldn't have I and do and I, because the result of so you have just and I, right? Everyone's clear on what that would be. If I is an int and I is int star, right? The pointer to the int. You can't do and I. And the reason why is that first and, the one that returns just regular, pointer to int and I, the result of that and I is an R value, and you cannot take a pointer to an R value. As in, you first need to assign it to an L value, so you can do x equals and I. Right, so now then you can do and x, and then you've got a pointer to a pointer. But for each level deep you want to go, you've got to first assign each one to a real variable. So, also, I mean, yes. If you're writing pure C++, then you should never really be going that deep. If you're interacting with C libraries, then generally you should never be going that deep either. A common thing to do in C++ is take a pointer to a pointer. But the reason why is that you just declare a pointer, don't stick anything in it, so you have an empty pointer. You give them the address of the pointer, and then that C function will allocate an actual object and then set it for you. But it needs to take a pointer to your pointer so that it can actually set your pointer, right? In C++, if you wanted to, you could have a reference to a pointer instead, but not in C, so therefore pointer to pointer. Okay, so we have again our lovely int I equals 0 and our int j equals 1. And now we've got a pointer to the address of I, so p is pointing to I. And then without actually doing anything to p, or actually making any use of this at all, we decide to just reassign p to point to j instead. So, is there actually a, come on. So we can dereference a pointer. Hopefully this is a bit more useful example. Yeah, this is better now. So we have our basic I. This is a value that lives on the stack or wherever. We then take the address of it. And then this obviously is now assigning into what P is pointing to. So anyone have a guess what it's going to do? If I look at I after this is run, what do you think I is going to be? 4. Precisely. And I is now equal to 4. So when we call star P, this is again getting into the sort of slightly deeper language syntax, you actually get a reference to the underlying object. So that essentially means that the result of this call, if you imagine that star P is some sort of fluffy syntax for a special function call, then this is like a function saying, please get the address, find out what lives there, and return me a reference to it. So this is literally returning a reference to I. Star P returns a reference to I. So that means you can view it. So if we are reading star P, if we didn't do this line, we would get obviously 0. If we're writing it, then I is then updated to also be 4. Okay, so exercise time. Do you know if he actually did? There's not a GitHub. This is that. They just want to go to one box.
I mean, people can go with C lions, those who have running, and others they can use one box.
So if you have C line, which hopefully everyone does.
Is anybody without the IDE? Raise your hand if you don't have IDE. If you don't have IDE, are you condected to the internet? So then we want you to open a website called WAND, like Harry Potter, wandbox.org.
Wandbox.org, yeah. I mean, you don't have to use... Oh, no, it's done it again. You don't have to use Wandbox if you don't want to. If you've got your own way of compiling code, you don't have to use C-line. Okay, there we go. I don't know.
We have two ways of doing that. Analog and digital.
I have an alternative solution. If you can't see from the back,
come closer.
Or we're live streaming it on YouTube. You can just bring it up and silence it.
I mean, there's plenty of space. There's a big gap there. So if everybody will be closer, you will definitely help with the Zoom.
You could also go to zoom.us/j/540236643. If anyone wants to not use the YouTube solution, tell me and I'll reiterate that more slowly. So yeah, this is exercise 4. This relates to the references exercise you did last week. Oh, that's important.
Yeah. Oh, no, this is the references.
Come on. What are you doing in here? if anyone's having any trouble, I can come over. Justin can. Jacob can as well.
Ricky as well.
Ricky as well. We've just dropped you in it, mate.
Can I ask people who can help just raise their hand so people can see around your so see these people? Yeah, so if you stack, raise your hand. One of them will give you a hand.
I'm going to whip through the slides real quick just to see if I can find that. So the answer is get C-line and create a new C++ executable project, that first bullet point. Is there anyone who didn't do the exercises last week? Cool.
Sorry, for some reason I cannot connect to the Wi-Fi. I'm putting the password. That one, right? See, guys?
Put a password.
J. That one. Then I join. It's not connected for some reason.
Hold on. Is anyone else? Who's connected to the Wi-Fi here? Okay.
It's working. There was somebody last week, it didn't work for whatever reason. Do you have mobile phone? So try jumping on your yeah. I mean, use personal hotspot. I mean, we're not transferring lots of data, so if you can, so at least that gives you the one that you want to have it. Before we diagnose what's happening, you might have to contact the building ISP and what's the solution? I can help you.
Oh yeah, sure. The
So you have here a function. The swap seems to be quite best. No, it's not. Okay. So I think that the first trick we all exercise. I didn't do that. Most of the time, I did them wrong way.
How are we getting on? Anybody needs help? Anyone who finished, raise your hand. You have a question or you finished? Yeah? Jacob will. In the meantime, just a reminder, because some people arrive a bit later, that's the username and password, so that's the SSID and password for the Wi-Fi, if you don't have it. If you want a license, email me at tom@pcservice.uk and I will email you as soon as I have another batch of the licenses. If you want to the latest updates, follow me at the Twitter. And finally, put your name if it's not released or put a tick on the classes you were attending to.
This does. It's step on. Yeah. This does. Step on. I spent last summer, sorted out quite crazy, like all of Sunday.
How are you?
I'm okay now. Still a bit knackered out, but
It's always frustrating when something doesn't work. Oh, we have another person.
Yes? Do you understand what's happening?
Yeah, how? Exactly.
It's like the one that's yeah.
So what's happening? Why there is that an asterisk by S1 and S3?
That's what confused me at first. Because you had the concept of references. I didn't
5 more minutes, folks. 5 more minutes.
and then we'll carry on. You have the concept of references separately.
Why the S1 and S2 have asterisk and S3 does not?
Yeah.
Then they're not preferred. It's not preferred. Yes, S10 is correct. Reference is if you use, let's say, reference, it's like a pointer, but you don't use the star to ask to the reference, just to ask that. You just use the name. So, for example, let's say the one of the reference to int, yeah? So you use, let's say, name, so let's say int A equals ampersand, and then we work out the int you want to make the reference to. So you have B, yeah, so ampersand B. So then the ampersand, so the first doesn't carry the so why do like this? We close bar. So that's when we have the A, one variable A of type int is bar. I want to reference to that. Meaning line that number int download custom and convert it to pound voice.
You create, you created a concept of one.
Yeah, I'll convert it to hardware.
It's the same thing. That's what I went to do first when I read the thing about using the Excel operator. Addressing this.
So we can think the reference to it. So that becomes some display. So I'm changing B for when I print A, let's just change the form.
Let's have a look.
It's like this room with two doors. I create another door which points to the same room. So, sorry. A equals 66. A
Printing for it?
That's the point. Mainly trial and error. So this is the process that passing in two strings, moving around until it finds two strings.
A and B. This one, this is now should be 4. So that's 4. And this one should be 6. So this one should be 6. See, A and B are 5. A and B are 4. I'm saying that A and B
Just goes on to the next. Just goes on to the next.
No, it doesn't find it.
I'm trying to return that memory address.
Is SI is equal to S, right? You know S is X, Y, I. Like, so declare a child star, it's equal to S plus I, and then return S plus I when you currently do that.
Okay.
You want to return the first current,
So
once you know the first character match, Y, S, I, you don't need to print it. What's the function?
means the output.
S is the
Says, I'm forcing you to straight weights and everything you have.
Does that say to return a child star as well?
Yeah, that's the question. That's the bit. I can't do it because
That's not very
it
nice.
says incapacitate between the input source and
Yeah, which is tricky. That's not very nice.
I can't do it.
Well,
So I'm getting the correct answer inside.
yes.
I can't get it outside.
I'm going to override this exercise and say that you can return a construct. That's is that from
I know what my problem was. I was trying to get still doesn't return the correct.
No. What are you doing now? Oh, you want the address? Sorry, you want the...
I want the address. Where this man I'm not sure that's the answer. Is that the answer? Is that the question?
Show me the question. What's that?
Sorry?
What's it's indexing into it.
Sorry, which one? It's the new line.
Right, is everyone good to go? Sorry?
So it's 66. 24, 66.
Actually, Tom.
So how you get the size?
Tristan. Justin on site. Justin, he's going to forward it to you. Alright, is everyone ready to continue? Yeah? Alright, we're going to continue. So, the solution, as you can see, is fairly simple. We have our swap function, takes the pointer to a stood string, called it P1, takes another pointer to a stood string, we've called it P2. We create a temporary because that's super easy. We then dereference P1. So, strictly speaking, does anyone know what this is actually doing? And when I mean what it's actually doing, I mean we've obviously got a pointer to a string. So actually, let's wind it back slightly. What is auto going to actually be? What type is auto going to be? You know, obviously. Sorry? No. Just a string. Just a stood string. So that's the first thing we know, is that it's just a stood string. So this is obviously returning a reference to the underlying string, because we dereference it, so we get the underlying object. So when it's going to fill, this is going to be filled in, but what's it going to do? Because in C++ we have two operations that can happen from an assignment, a move or a copy. It's going to copy the value, right? So our temp is actually going to copy it. Then we're going to dereference P1. So then this L value here is going to get the value of P2. So is it doing the same thing again or something different? Is it a copy or a move? Yeah, so we've copied P1 once here, and then we've yet again copied P2 here. So now at this point, we've got P1 being equal to P2, and temp containing a copy of P1. For efficiency, and don't worry about this, this is just trivia, don't worry about memorizing it. We could actually use stood move here. Where's my mouse gone? We could actually use stood move here to optimize out, to not copy. Instead, temp will just gut the value from P1 and leave P1 empty, rather than making two copies, which is a bit slower. But again, don't worry about that for now, just a bit of trivia. And so finally, we then set P2 to temp. So they are now swapped. Hurrah! And then in main, we've got my where is Tristan. We call swap. And if we assert that this equals this, it should obviously fail horribly because they have been swapped. Any questions on that? It looks relatively clear, straightforward. One at the back. Sorry? Yes, absolutely. So, oh no, don't do that to me. So it wouldn't. This would not be auto. It would be stood string. Ideally, it would be yeah, stood string. You are actually completely correct. It's not a pointer. Sorry, that's been the wrong line. Yeah, stood string on its own here would be fine. You could also do stood string and take a reference. If you know, sorry, that's completely wrong. You couldn't. It would corrupt it. But yes, just stood string. Absolutely. Okay, on to null pointer. It also has its own type. The type of null pointer is in the standard library, and it's called null pointer T. So you do actually need the standard library to get its type if you want to access it as null pointer T, or you could use decal type null pointer, which is actually what the standard library does. Decal type is when you want to just dynamically get the type of something that already exists. But again, not massively relevant to this discussion, just trivia. So for example, ta-da, inst rp is It's a null pointer. It doesn't point to anything. If you try to use it, if you try to read this, if you try to write this, you will crash. If you do this on an, or if you do it on an embedded system where somehow address 0 is valid, then you strictly wouldn't crash, but it's almost never what you want. If you're writing standard programs that are on like Linux, Windows, dereferencing a null pointer will crash you. In C and in older C++, we had this macro null, which was problematic, actually. It's just a macro that is 0. And the reason that it was problematic was that, say you have a function that takes an int, and you also have a function, and you have an overload for that function, so it's the same name of the function, it takes a pointer. But if you pass null, you may want it to call the pointer overload, but it might just call the int overload because it's just 0. Now with this null pointer thing, if you do null pointer and not 0, and you have two overloads, the one that takes the pointer will always be called because it was null pointer. And if you pass it 0, it will just call the one for an int.
Okay, you mentioned that if I get to the null pointer, I get an error, so that address is not accessible. Is there a way for us to make some part of the memory not accessible? As you present a notation which has a password and I don't want someone to hack and speak and where it goes memory.
Depends on your platform, really. So Windows has an API for this. You can sort of lock off an area so that it's only accessible to your application, but this is all OS API functionality. If you were sort of building your own device, then yeah, of course. In Windows, it doesn't really matter what the address is strictly. You don't say, I've decided this address is restricted. You have to ask it like, I would like this much memory, and for it to be only accessible to my application and secured away. And it gives you back an address. You don't get to dictate the address. Nan.
Yeah, no.
There's floating point. There's such a thing as floating point exceptions, and I believe that in that case you can get them, but they are actually part of the architecture. So if you're strictly speaking about the C++ standard, no. If you expand to the sort of the machine itself, then we can talk about it. But if you're focusing just on the language, it doesn't have no concept of it. So yes, remember to always initialize your variables. Obviously, if you do declare a pointer, do set it to null pointer, just because if you do make a mistake, then having it dereference null pointer means that you get a nice error from your computer. You still crash, but at least you know that it was null. If you just do int start I with no assignment, it's going to end up with some random value from whoever last used the memory, and then you're going to try and dereference it, and it's just going to be random garbage and be more difficult to debug because you'll probably wonder why it's some random value. It's the same as having non-pointers, right? If you just declare int I and you don't do int I equals something, it will just literally pick up whatever was in your computer's RAM from whoever last used it and just be some garbage stuff. And as I said before, do not dereference invalid pointers. As in, don't use them. But don't try to use them until you assign them. Okay, dangling pointers is a similar scenario to this is essentially something that is invalid. The word dangling is a slightly different semantic, but it is still encompassed by the concept of being invalid. So obviously, because we can change the address that a pointer holds, we can of course get into situations where it's no bueno, right? So say we declare null pointer. We'll go into some inner scope. Let me just go here. So does everyone understand the idea of an inner scope, what this signifies? It means that the lifetime of these objects is only inside here. Once we go past here, this one's gone. This one obviously is from up here, so it's outside of it. So this will live on, but this will not. So like undefined behavior right there. I is gone. It's wound up the stack. Sorry? Probably not. You might, but I doubt it. One thing you might find is you could probably try to run this example yourself, and you may even find that you don't get any error. And the reason why is that if you step this in main, it will go inside the compiler. What it's going to do is, or assuming it doesn't optimize it out, it will wind up the stack pointer to make space for I, do this assignment with a pointer, and then roll back the stack. But this is still pointing to a valid stack address. This will probably actually not crash in that instance. Now, on the other hand, if this was actually some object allocated through new on the heap, and you assigned it to it and you released it inside here, then it would likely explode magnificently if the OS took back the memory quick enough.
But the null pointer there is still an address.
Sorry?
The null pointer on that has an address. BTR has an address.
Yeah, which would be 0. Okay. Null pointer is the 0 address. Also, if you do if pointer, if you did if pointer when it's this, not when it's this, when it's null pointer, it evaluates to false. So if you set a pointer to null pointer, it is considered false. So as a way to check if the pointer's good or not, right? If pointer, cool, I can use it. Probably, if you've done this to it, if you did this to it, it would still be true. It's now true here, but it's not actually usable anymore. Not legally usable anymore because you killed off the thing it points to. So, but generally speaking, if you're not referencing invalid memory, as it were, when you set it to null pointer, it's false, and when you do set it to something, it's no longer false. Cool. So yeah, this is a dangling pointer, and dereferencing them is always an error. Just because it happens to not crash in one particular situation doesn't mean you can or should do it. If you
that points to a memory address, the original variable is gone, is it possibly going to point to something else arbitrary to set that address?
So if this is what I'm saying. So if this is the only thing you did, most likely it's that. If you then started allocating new objects here, yes, it's very likely to point to one of those objects and blow up, or at least, or not necessarily blow up, when you would corrupt those objects. So today we have not learned about references or const references, or passing by reference, but we have learned about basic pointers. And apparently, wow, we're on homework already. We haven't even got anywhere. I tell you what, we're gonna switch this up. So this is not homework. This is an exercise. So can everyone get on to exercise 3 of chapter 17?
Everybody got the exercise? Do you know, or do you need the details for the exercise?
Tell you what, let me.
This is the homework we were doing last week.
You done it?
Yeah. Well, apart from question 5.
Pointers.
So write the function.
Yeah, what's the best good way we can communicate that?
I can type you on Slack.
Don't do something like that. Something.
So what I've got I'm fixing a class, I've built the character. Yeah. So I've got that part. So
What's the instruction? Don't seem to find Slack. I can't look at Slack right now. Can you just give me the book or something? Huh? Sorry, I got it all.
string before you put in brackets, and I assign still the character is that right, or are you saying
Okay, we've got it here.
oh, I see, right, that's not okay. It's in that string, that's in the book, that's in the book. So that I missed. So it's a C string, you do C string.
Alright, so there's the exercise up there if you want to do it. Show me the rest of those exercises.
Okay. That's okay.
The copy, the text, and the forward one.
I can. Say when.
So why don't we need to use the address of that person? This is what I don't get with because there seems to be some times where you need to use the address of that person.
Well, I think it seems to work. You just treat it as an array.
Okay, and I need to use it.
What you got to remember with that one is that when you get to the end of the array, get a zero.
Bottle opener again.
What?
Yeah, that's the last question. Oh, right.
Yes, right. So you need to return.
Don't need to use some zero.
Yeah. So it's just basically on inside lessons. Yeah.
So I'm looking for the zero at the end of the C string. Rather than big size up the size. That's X is the middle. Yeah, X is what we're looking for. Jumps out, check with one, yeah.
Saying that in this I'm not convinced that debug is wrong. I'm not convinced that debug is right. Because if this was wrong, that would print out C style string, and it does.
Right, but it's printing out C style string there. Inside the. This is what I couldn't. See, this is the.
Wait, stop, yeah. It's already pointed.
If I just get the C style string, I don't get the address.
Obviously, that's what it is.
I might answer the wrong question. I guess I could have printed it inside something. This is more by trial and error at this stage. I think
really want to see this stuff.
I'm just trying to solve the rest of the PTR. Well, no, let's do charge because that was the original question. No, but I can't print it out.
You're not printing out the address of that thing. You're making the compiler create an address to the address.
Yeah. But why can't I just return that?
Because that's just a made up phone. That's why it doesn't matter. Having the compiler make a made up memory address to store the memory address, and then you're printing out that memory address.
Okay.
So you're imagine this, right? You've got your you've got the address for the actual text bit, right? Yeah. And then you say, invent an address for that. So it goes and finds an address here for this. Yeah. It's actually so that it just prints out a random address here. This is it. Just a thing you call to make up and whatever. But why does it match the address in this string? Each time you're calling it, it's going to do it up. It's going to use the stack, right? Because it's not going up the stack. Okay. So, give me a second. Yeah. Okay. All right. So, let me just grab my phone because it's still busy. Pointer. We could use printf actually. We could use start p. Percent p rather. Okay. That was what I was sorry, I missaid. That's always what I'm printing out here. That's what I'm printing out. So, size of. The SI is sharp. This is point string. If you index it, you'll get sharp. That's how you compare it. Yeah. Let's do something else. It must be this one. There's a couple of days since my point was that those two. Right, that is the real point. Just forget those. Forget those. These are the actions. That's 40A1A. Yeah. And that's 40A1B8. So if you take this, subtract that from it. Okay. So, next calculator. No, I don't. You're on Windows. Do I? Oh, okay, yes. So, let's do 40A180. That is 56 characters in. Yeah, that's correct. I shall examine that. Thank you very much for my ledger. There is a way, I believe, to print pointers as they are properly in with cout. I I just haven't done it in so long, I can't remember.
No, sure. But no, I'm glad I got that bugging me. No, this is special Friday anyway, so we'll go through it anyway. I've got used to the idea that when you want to create a pointer, you have to pass the address of something. So you have to use the address operators to get the address of the thing you want to receive. You want string, pointer, string, first. So all you need to do is loop around. But surely I need to, right. Yeah, I mean, I got it. It should work. But I just don't know why I'm not getting my head around the fact that this is an address somehow. H is the address. Or the address of it.
I'm looking for more shit. But no, what's up? What's up? Huh? Kind of what?
I'm trying to figure out the exercise.
Well, my internet's not loading, so I might as well help you. Go on.
So let's say door A is 65, lowercase is 95 plus going on 2. Give me the uppercase A. From the uppercase, the lowercase A. The French people, out the I,
Oh, when you iterate a string with a range space for loop, I is the char.
yeah.
So why are you doing at? No, because I is the character. You already have the character. So you have a problem. I should have done it.
Oh, so you dereferenced it on the I. So I'm doing the I. Oh, cool. Because I'm counting those, some script operator gets an address. Yeah. To me, that means a lot. Yeah. Okay. You see what I mean? And you were just doing it like you see.
But yours are lines.
Also, you still have a bug, I'm afraid. I'll tell you if you don't figure it out.
Okay.
Yeah, it's slightly different now, aren't they? It's more strict.
I think it's this part.
Yeah. If you get into the if you do that.
You have 2 bugs.
I like to know that that's the
I'm thinking for the
One second on the left. What do you mean?
Oh, okay.
Oh, yeah.
or I can just nick. But also I can't. No, I can't cover that. It's too cold.
How about doing the class on Git, setting up a valid service?
Okay. Yeah. There's no copy. So you don't
Do you want to do it? Yeah.
We can if you run out from the.
We're out of flight. We've run out of flight.
We can. How about
We've run out of flight.
How about creating visual slides on the slide pointer?
I'm kind of wary. I don't want to do something that's going to piss up his schedule. So he's going to come back into it. So I don't want to do something that's just like, well, great, just fucked up the whole.
We have to cover something as long as we're sitting bored looking at each other. So if you're okay with that, I would cover the smart pointer.
Yeah, but sometimes.
Did I do smart pointers or did he? Who did smart pointers last time?
We didn't.
We didn't.
I don't think we did smart pointers. I mean, we did like a basic, but I would do some exercise on smart pointers and so on.
Did I do smart pointers? Maybe. Maybe I did smart pointers.
Yeah, it does. Now that I get it. Okay.
You know what? Let me just do this. I've got 25 messages. Why did it just go like that?
You don't want to reassign it, do you?
Bear with me, folks. Bear with me. The internet is not great today, it turns out. Did I do smart pointers last time? Who did smart pointers? We did cover smart pointers in the last semester. I know we did. Was it me or who did it? Me or Tristan? I'm looking. I will look through my slides when I fucking load. week. Can you look through the blogs or something? I don't want to do smart points, it's probably too advanced. I'm going to do Git. Sorry? Because it requires templating and it's a bit much. I think I'll just cover. Hmm? Yeah, it's too much. You got a template. I don't want those templates either. I don't even know templates. Throw me at the deep end. People still playing with exercises, or do they want something else? We've managed to whip through pointers quite quickly, so I'm sort of going through my library of stuff, and we've got some choices here.
Maybe we can show the solution.
I was hoping, Tristan, that they had more in the way of slides, but it turned out not. So, I think in terms of where everyone's at, there's sort of two things there's three things I could cover here if you're interested. So I would recommend we can either try to go through Git, as in the version control, if anyone's interested in that. CMake is also probably a decent one to do. CMake is the scripty thing that lets you build C++. Basically, there's several competing ones, but it's the main one. And then the other one that would probably be okay to understand would be C++'s move semantics, if you want to stick to just the language itself. So we've got one vote at least for CMake. We've got two votes for CMake. Okay, we've got 5, or maybe was it 6? 7, okay, for CMake. Oh, you're Git, sorry, I'm talking about CMake. So who's for CMake? Okay, who's for Git? Just 5, okay, or 4, sorry. And who's for C++ move semantics? And who's just bored and wants to go home?
Everyone else who didn't put their hand up is CMake.
Yeah, so it seems that CMake is actually the winner. So we're going to give this a go. The internet's like dial-up at the moment, so I might switch it to my tethered phone actually, that might fix everything that's wrong with the world. Let's see, I'll turn off the Wi-Fi. Oh, no, it loaded. Amazing. Incredible. No, it didn't. No, it's slow as hell. Come on. Why is this not working?
You need some help?
I'm trying to tether this.
You want to go to my one?
This should just work. It's an off one.
Okay.